In this video, I'm going to show you how to do Edexcel A-Level Maths from June 2022, Paper 1, Question 13. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition, and both online and in person, and I live in Buckinghamshire, England. Please like and subscribe. Question 13, Part 1 says, in the arithmetic series, the first term is A and the common difference is D. Show that this formula is true, which is the standard sum theories for an arithmetic series. So this is a standard proof that you should know. So the proof goes like this. So the sum of n terms would be A for the first term, and then A plus D for the second term, and so on, all the way up to A plus n minus 1 times D. Now if you reverse the order, you would have the sum of n terms, now the last term first, so A plus n minus 1D, and then all the way back, then you'd have A plus D as the second to last one, and then the last term here, I'll put brackets around the last one, is A. Yeah? So this is line 1 and line 2, and what you do is you add those two equations together. So you have 2 times Sn, and then this pair will add together to make 2A plus n minus 1d times n, and then all you need to do is divide by 2. So Sn is n over 2 times 2a plus n minus 1d. And that completes part 1 of the question. Okay, so part 2 of the question says, James saves the money over a number of weeks to buy a printer that costs £64. He saves £10 a week in week 1, £9.20 in week 2, £8.40 in week 3, and so on. So that the weekly amounts that he saves form an arithmetic sequence. Given that James takes n weeks to save exactly £64, show that this formula is true. N squared minus 26n plus 160 equals 0. So all we need to do is substitute these numbers into the standard sum equation. So here, A is the first week, which will be 10. D is the difference between weeks, which is minus 0.8, and n we don't know, but we know that the sum of n terms is 64. So if we substitute that in the equation, we get 64 is equal to n over 2. 2 times a is 20, and then we've got n minus 1 times d, which we know is minus 0.8. And if we simplify that times by 2, we would have 128 is equal to, now expanding the brackets here, we're going to get n times 20, so that will be 20n. We're going to get n times minus 0.8, but also times an n, so minus 0.8 n squared, and we get minus 1 times minus 0.8, so that will be plus 0.8, and it's also times another n, so that's plus 0.8 n, which we can now get 128 is equal to minus 0.8 n squared plus 20.8 n. If I go to the next line here, we can bring everything to one side. So bring everything to the left-hand side, we'll have 0.8 n squared minus 20.8 n plus 128 equals 0. And if we divide by 0.8, we will get n squared minus 26n, so 20.8 divided by 0.8 is 26, and then 128 divided by 0.8 is 160 equals 0, which is a proof that we want. Okay, now for part B, it says solve the equation, so we just need to solve this quadratic equation. It factorizes, so we need two numbers that multiply to make 160. They're both negative signs of both brackets, and add up to make minus 26. So it's actually n minus 10, n minus 16 equals 0. So therefore, the solutions to the equations for B part 1 are n is equal to 10 or n is equal to 16. And then for part C, it says, hence, state the number of weeks that James takes to save the money to buy the printer, giving a brief reason for your answer. So what would happen is after 10 weeks, he's actually saved enough for the printer. So the answer is 10. Well, why is it they're giving a second answer? Well, if you look at it, the amount he pays each week decreases. So what would happen is in the 11th week he will have paid more than £64, and in the 12th week he would have paid more. And at some point the amount that he's paying becomes negative, and then so he sort of overpays and then gets some money back until he gets back down to £64. So the answer here is 10 weeks, because this is the minimum time, and we can say 16 weeks corresponds to oversaving, and then followed by saving a negative amount. I'll put not 16 weeks because, just to make it very clear that 10 weeks is the answer. Okay, and that completes question 13.